Hello guys, how are you? Today we are going to talk about a topic which is a painful topic for most of software engineers, tech leads and architects out there. But we are not going to talk about the pain, but we are going to talk about the solution for the pain. Most of us going through a problem and going through a complaint saying, okay, this is slow, right? We create a system, we deploy a service and it says it's slow. And sometimes it says, sometimes it's slow, okay? But we are not whole responsible people for this problem. The network involved here, the machine involved here, the infrastructure involved here, so many other factors involving here. But we always get the burden because we are the one who developed the solution or a service, right? In this industry, unless otherwise you find the fault, its guilt is always with the software engineer about the slowness, right? So that guilt is always there. My service is slow. Unless otherwise you find whose problem is this. So today I'm going to show you how you can troubleshoot this type of slowness and what are the things you need to look and how you do it and what are the tools you can use for this type of things. In order to understand this best way, you need to make sure you watch my last two videos which I explained about how TCP works and how HTTP works. Because most of the services we implement are run on HTTP, and so we need those understanding in order to get this well, right? So, all right, without further ado, let's start, but make sure you subscribe to the channel and also like this video. I'm pretty sure you're going to like it, and share to your friends so they will also can learn something new. Okay, you can help to relieve their pain, right? Okay, so as usual we have our last program which is that sending a HTTP request, but only change I have done is I changed this to post instead of a get, right? And I have a two payload ready. One is I'm going to just send a simple text payload, and other one is I'm going to send a large file to the backend. Okay, but I don't do anything with that. I don't do the processing, and that's it. All right, so now let's start to capture our loopback interface, and usual our port TCP 8191, right? That is the port we are going to use here. Okay, and I'm going to start the server, and the server is running, right? Nothing is there. Okay, so now first I'm going to send this initial transaction. Okay, I send it, it's done. Okay, and I'm going to stop this capture. So we went through this multiple times, right? So initial transaction is sync, act, and act, right? Sync, act, sync, act, whatever you can call it, but that is the initial handshaking transaction, right? Three-way handshaking, right? So, but this time we are going to look something more important here. I have added two columns for this one. Then you can Google how to add the columns to the Wireshark. So one is delta time, another one is a calculated window size, right? I'll show you why this we need. So now you can see here there is something called window size. Okay, forget about this window update, right? Well, I'm going to cover that in a while, but forget about that for a moment. So now you can see here, you send the sync from the client to the server, right? If you see here, you can see it's a client to server, right? There is no HTTP involved here yet, right? And then the server sending the act and the sync, and then you are acting it, and then the window update. Okay, forget about this window update for a moment. All right. So initially, in the initial request, the window size, it says 65,535, right? 65,535 is the window size. But what is this window size? Window size mean, in other words, my receive buffer size. Okay, if it's a client, the client receive buffer. If it's a server, server receive buffer. That's the size. That means that is the maximum buffer I can get from you to me. Okay, so that's a one time. This is the only maximum window I can accept. Now, in this is a Wireshark thing, right? Usually this window update send after Windows 0 window packets, but in this case Wireshark tagged this as a window update because the server just sending a window update. If the server sending window update without anything else, the Wireshark tagged that as a TCP window update, right? So that therefore, just forget this for a moment. Now, if you see this carefully, you can see here, right? If you get this transaction, this particular one, right, which is going from client to the server, it says window is 6379. If you get initial one, window says 65535, right? 65535 bytes mean it's huge. Just think you're going to upload like 1 GB or 2 GB file, or your download, doesn't matter which site, download or upload 2 GB file, right? So just imagine you send 65532 bytes and then act it, and then you send the next chunk, you act it and send the other chunk. It will take forever to download, right? Because it's very slow. 65535 is it's just a 65535 bytes, right? So now to solution, because the TCP born in like decades ago, and so therefore TCP those days they didn't predicted that there can be a gigabyte size files, right? So TCP window size they were planned for like 65535. For those days it was more than enough. But with the protocol growth, when this with network growth, when we trying to start huge files, we wanted to have more space. So what they have done is, if you go here, you can see the option. There is a flag called window scale. Okay, window scale. Window scale mean, this is 6 mean 2 to the power 6. That means 64, right? So this is the Wireshark make your life is saying multiply by 64. That means, though our initial negotiation is 65,535, I'm okay to accept 64 times as this, right? You can multiply window by 64 and I'm going to accept that. That's huge size. Okay, right? That is, now we know what the window size. Window size is what? The initial negotiation is the receive buffer. So therefore, since it is not enough, the TCP design came up with the window. This is the TCP option. In the option, we are saying WS or else window scale. The window scale is 6 mean 2 to the power 6. That means initial value we can multiply by 2 to the power 6, which is 64. These numbers can vary depending on the TCP stack you are using. But that is not the important thing. Okay. Now, here's the thing. If you check some packet like this, right? If you take some packet like this, okay, and if you go here, you don't see this window scale, right? You don't see that window scale option. Why? Because that only take place during the handshake. Okay, that only take place during the handshake. So if you analyzing your slowness, your service slowness using a TCP dump, you need to make sure you capture these sync, act packets, right? Three-way handshaking, sync, act, or sync, act, whatever. Those packets you must capture because you need to make sure the bandwidth is using in the full scale. Okay, right? So I'm going to show you something different here. Now I'm going to clear this out and upload a new file, right? And I'm going to oops, sorry. I made a mistake. So let's go there, right? So now what I'm going to do is, for the same file, to make sure, let me to close this and start again, right? And there will be some sync, the packet captured. So I'm going to refresh this, right? Cool. So now what I'm going to do is, I'm going to upload a large file, right? That file is 262 kilobytes, 282 kilobytes, okay? 282 kilobyte file is a large file. Now see what's happened when we upload this one, okay? So now we don't have anything, and here we upload the file, and I'm going to stop it. Now, if you check this one, you can see, right, here, again we have a sync, act, right? Forget this part because it's a connection closed from the last connection because I use the same REST client. So the client was hanging the connection. So now connection is closed the connection because of the server is not ready. And then because they missed the ACK, right? So it start the new connection. Now you can see here TCP window update. Okay. So now initially start with the 65.535. But if you see this one, right, if you see the server ACK, right, server sync ACK, and if you go here for the options, okay, not the flag option, the window scale is 6. Now what we need to check, if you see this calculated window size, you can see it's dropping, right? It's in a 40,000, 39,000, 37,000, 35,000, 34, 34. Again, go back to 40, right? And here it's come back to 29, 27, 27. See, 22, 21. Right? That's very important. Why it is very important? Now, when you're dealing with this calculated buffer window size, that means you are saying, I'm open for this type of window size. So now just assume I'm the server, you are the client. So I'm saying, hey, I have this size to send, right? Let's say, to get the math easy, let's say 1 million, right? I have 1 million size. So now we are sending 1 million data to me. Now I have this 1 million. So, but I am just a server, I'm just this server who is listening TCP stack, but some other application is on top of me. Because I'm just a protocol and the application in the layer 7, the application is pumping something to you and you're sending it to me because you and me are TCP, right? We just don't care who send and to whom we are sending. Someone give the data to you to send to me, you send it to me, then I take it and I give to someone on top of me, right? On the layer 7. So now that guy need to take it from my buffer, right? That guy need to take it from my buffer. And you get 1 million, right? Then I acquit to you. So meantime, this guy is taking it. Let's say he took 900,000 consumed from my buffer. See, my buffer size is 1 million. Okay, my buffer size is 1 million. So now he took 900,000. Okay, he took 900,000. Now, okay, let's easy maths. My buffer size is 100. Okay, you send me 100. He took 90. Now 10 is remaining. Okay, how much I can ask from you? 90 more. Okay, I can ask 90 because my full stack is 100. So you give me 90 now. Again, my size is 100. Now he took 70. 30 remain. Next time I'm asking 30. So now you can see this is keep dropping. It's fine. It's not a big deal. But what the big deal is, your application is slow and you can see this calculated window size dropping and it's hit like almost 0. That's something we need to be careful. Why? Because then though we transmit the data in a high speed, your application who is in the layer 7 don't consume the data in the same speed. Okay, I'm saying this is layer 7 to understand this easily because it is not just directly layer 7 come and take it, right? So there are other processes going through, but as an easy of understanding, that's how it works, right? So now, if you, let's say for some reason, I'll show you a cap file. Let's say for some reason this hit to the 0. Now we call it's a 0 window situation, right? Now server tells you I hit the 0. Now that means I don't have anything in any space, all 100 full. That guy is not taking data, right? So now you need to wait. Okay, you need to wait. And let's say after 1 second later, I'm just saying window update. Now I got 30 space, just send me 30, right? So now you can see there's a lag because of the 0 window. There's a lag. So if you see your system is slow, your service is slow, and also you see 0 window packets, which I'm going to show in a different cap file, right? And then you need to solve that problem. You need to figure out why it is slow, right? Why it has a 0 window, because you send high speed data, it doesn't consume in the same speed. Okay, That's the one problem we need to identify, right? Now we discussed two things. One, we need to make sure you capture this file from handshake itself, right? Sync act, and then because that is the way our negotiation happen, the Windows scale negotiation happen, then you can figure it out, right? So now next thing is, if you see this one, this particular, let's get the handshake, right? So you can see the handshake the responses come RTT, right? It's coming within like microseconds, right? Not millisecond, right? 5 milliseconds, because this is, I'm dealing with the same server, right? Because the local host is the same thing, so it's very fast. So this is also very important. If you see there is a delay here, that is something you should be cautious. Why? Because to send the packet to the server and that come back from the server, you take this much of time. So every handshake, every act taking this time. Now here is the problem. Okay, here is the problem. Okay, let me show you. Let's get this one. Okay, so you can see the TCP segment length is 16,000, right? 16,332, right? So I'll show you how this come. Now what happens is, I keep this length in my send buffer. Okay, now I am the client, you are the server, right? So I keep this in the send buffer. I send this transactions to you. So you can see here, okay, the length is 16,332, right? So therefore, the sequence will go 16,225. Why? Because previous sequence was 193, and then we are sending 16,332, right? 16,332, and therefore these two added together, and then the next sequence will be 16,525. So now I am sending, I'm the client, you are the server, right? I am sending this 16,000 what was that? 16,332 byte to you. Now you are acting that to me. Until you send the ACK, it will be in my send buffer, right? Understand? I got 16,000 bytes and I'm going to send it to you. I send it to you and you need to act that to me. That's why when you send something, okay, forget about the 16,000. If my sequence is 1, if you are sending 5 bytes, right, you are responding me for act as a 6. Why? Because, okay, let's take this one, right? Sequence is 0, right? And then act come as a 1. Why? Because 1 would be my next sequence. That tells me you got my data, right? So when I am sending 16,332, right? So if you see, this is sequence 193, right? Length is this, okay? So now you can see, and you keep sending, right? So see, here you get acknowledge for this one, right? You get acknowledge for this one, okay? 16,525 and ACK is 16,525, right? So now, when I send the data to you, right, let's say I send 100, and then when you are saying my next sequence would be 101, that is the time I can clear out my send buffer. Until the data will be in my send buffer. So, if this time is slow, right, if the server is taking time to respond, that means your ACK come in slow. If you ACK come in slow, mean I need to keep more data in my send buffer without clearing, even though I send it, right? And then my next data which I'm supposed to get, I cannot put it because my send buffer is full. I need to tell, hey, wait, right? So now your transmit is slow. That is not the dangerous part. If you go here, see this one, right? TCP retransmission, okay? So now let's simulate this. I had 100 bytes and I sent it to you. You didn't act to me. So now I'm waiting. I'm checking the time, waiting. When my timeout triggers, when my timer triggers, but you didn't act to me, I'm sending this again to you. But I'm sending again to you with the same sequence and the same acts. Why? Because when you get this, you need to make sure this is in case you got that, this is the same data. right? So when this connection is slow, you will see many retransmit, right? If even at least one direction connection is slow, you will see multiple retransmit. Okay, right? So that is also bad. So that is important when the connection where the connection is. So now this is little hard to show me from this one. The next thing I'm going to show you, but I will try. Okay, so if you go to this one, okay, if you go to this one, right, you can see something called time to leave. Okay, time to leave, you should start with 64, 128, 32, I don't know, with 32, 64, 128, 25, something like that. So time to leave mean, it tells, I can get indication what is the distance between you and me, how many routers we are going through. Okay, if let's say this start with a 64, because since it's the same thing, same machine, right, we already have a 64. Let's say this has a 60, that means we have 4 hops to reach from the server to me, right? So if this keep reducing, so that means we are taking a bad routing path. It's good to check our DNS and to see with why we take this much of long path to reach to the server. Okay, so like probably you are in Asia, but your server stays in the US region or some different region, so your latency is very big, right? So then that can cause tolerance as well. Okay, so this is important to see this time to leave number. It's starting from 64, let's assume 64, 63, 62, 60, something like that. So if it is a 54, that means 10 hops away. Right, so now when we check this traffic, you can see it's a ports, right? 64, 157 to 8191. So this is we call ephemeral port. It's not a big deal. The source port usually is a very dynamic, right? If I send the request again, it will be different port, right? We call it ephemeral port. You don't have to pay attention for that one, but you need to always see the server port is fixed. We discussed about why this is calculated window size is so important, and when it hit to the 0, what happened. Okay, but this is really hard to reproduce. I have my friend, he's a expert on these type of things. He have tons of cap files because his job, he's living by analyzing these network protocols and network traffic. So I talked to him and he sent me a pcap file which is we can see the 0 windows. Denver, thank you very much. So let me to quickly open that file, right? So in this file, you can see the calculated window size, it's keep dropping. But there's an interesting thing here. It doesn't go beyond our initial negotiation window size, right? Let's see why. Okay. So now you can see it's keep dropping, and here it says 65,535, and let's say it says I only have 11,680, and then window full, right? Then window full, right? So you can see it's sending TCP 0 window. So you can see here, okay, if you get this one, and after some time only next traffic goes. Why? Because it's in the window update. Okay, so you can see it's keep dropping 11,000, and then this guy is sending some large packet, right? And then it go back to the 2,920, and then this guy is sending this, and then it go to the 0, right? So why it doesn't go beyond 65,000? Okay, so if you see here, we discussed this, right? So we discussed it's so important, it's very important you to capture the handshake. If you go here, the client sending a handshake, right? During the client handshaking process, it is processing TCP option. It says window size, right? Window size is 7. That means it says, hey, multiply by 128, right? But see what server says. When the server acknowledge, server don't send window size. That means server don't understand something called window size. Window scale. Sorry, not the window size, window scale. Server don't understand. There can be multiple reasons. Something like server might be using very old TCP stack, right? It's a very old server, or maybe it's IoT device which is need to use a low TCP, low power, and low processing power they have, so they may use a very minimum TCP stack. Can be multiple reasons, but for some reason you don't see servers negotiating for the Windows scale. So therefore you only can send 65,000 data, right? But so using the 65,000 data, but looks like server don't read in the same speed too, right? That's why you can see it keep dropping, right? It keep dropping. It dropped to 26,000 and went up back, and then it dropped suddenly to the 11,000. That means it stopped reading it, and then it send the more data and go hit to the zero window, right? When it's in the zero window, the other side will not transfer any data. That is what the dangerous part of that. Let's go back to our usual capture, right? So this is also important, okay? So now what I'm going to do is I'm going to modify this program little bit. So what I did was I just changed this I added 1 minute timeout, and also I changed this to get, okay? So then it will be easy to check, right? So now I'm going to run this program, and instead of the rest time, this time I'm going to use a browser, okay? So what I'm going to do is I'm going to call this endpoint. So now you can see we are waiting, right? You can see we are waiting. So now you can see here, if you take this time, okay, it's a 10, right? After 45 seconds later, it's sending keep alive. It's sending a keep alive. Now the people will say, people will tell you, hey, your service is slow, right? Your service is slow. So now you can take this TCP dump, right? And you can ask, hey, a user may don't know how to do that, but maybe some IT engineer or someone install some software to capture the files, and they capture this and save it and send to you. So now when you analyze this, you can see, okay, this in the request, but after 45 seconds later, we are sending a TCP keep alive header. That means nothing wrong with the service, right? So it's nothing wrong with the network, because it's always delta time is within the range, right? Delta time is within the range, right? So just ignore this one for a moment, because this happened because it's take from the last time and this transaction. That's why it's a 45. But if you take the rest of the thing, it's falling like a microsecond level. So that means this is clearly not a network problem. But the problem is within the application. Why? Because once you give the request, until 45 seconds or 1 minute, it doesn't respond to you. So now you need to, it's the right time to go back and see why this happened to the service. If service calling another endpoint, right? Maybe you need to take a TCP dump from the server as well, right? So there are multiple ways you can take the TCP dump from the server, but if you are running on the EKS or something like that, that is not easy. So you can take the TCP dump from the next switch or a firewall. You can talk to your network engineer, and they will help you to take the TCP dump, or they will help you to monitor the traffic from the router, right? So you can ask, hey, I'm going to fire this request. The service will go and hit this particular endpoint. Can you trace that and send me a PCAP file? Then you can put into here and analyze what exactly happening and where the slowness is. I understand this is not easy to do, but that is the only way you can do it, right? So there is one small thing I want to show you. Okay, there's one small thing I want to show you. Okay, so I understand there's one point you may not clearly understood because of how this sequence number changing, right? How this sequence number increasing sequence and the act. It's really hard to show from this one because this dealing with the multiple bytes. But if you watch my first video, you can see clearly when you send the request. I demonstrate with the presentation as well as a real example. When you send the 10 bytes, right, it increased the sequence by adding that byte, because what is sequence number trying to tell you is if you send the 10 bytes to the server tells I'm next expecting 11. So when you see that the next expecting is 11, you can clear off your send buffer easily, because you know, okay, server heard me, it got my 10 bytes and now it's expecting the 11. So I send the last 10, so now that's 10 can throw away from my send buffer. That's what it's all about. Right, so we discussed a lot, right? So as a summary, you need to take the TCP dump from handshake itself, because that has so many tons of important information. And then you need to pay attention to this delta time, because that's a tell what's the round trip time to the server. If it is increased, if it's prolonged delta time, that can lead so many things, because then your access comes slow. Your access comes slow means you are trying to resend the data, or you are trying to you cannot clear your send buffer, so then your other data will be stay within your buffer. And also you need to pay attention to your calculated window size. If it is keep dropping, then there's a problem there, because your application is not consuming the data in the same speed you're sending. So you need to see what the stack is using, what the HTTP or any other client it's using, and so many other things you need to take care of. And also you need to see, is there any keep alive headers frequently sending? That means your server is waiting until you get this data. There are tons of other things we can discuss with this one. So what is the segment size, how the segment size derived, because for example, if you go here, if you go this one, right, not the HTTP level, right, if you go here, you can see maximum segment size. Maximum segment size is nothing but it's just an advertisement. It is not necessarily to be the same, but it tells you in a one segment how much data you can send. In our previous example, if you remember, and you can go back and watch that, the length was the message like 16,535 or something like that. Maybe not the exact number, but something like 16,000. The reason for that is because the negotiations tell that is the 16,000 bytes need to send in the one segment. So that's why it's a one segment, it's only send that much of a byte. But you keep sending, and then you keep collecting your acts for those, right? So but by just watching the video like this, you will not be able to understand how this exactly works. So I'm highly encouraging you, before you get the real TCP dump to analyze, create a very simple program like this and get the you saw what's my setup, right? I have a simple API, and then I have a Wireshark setup, and then I'm capturing packets. So do this, practice make perfect. So practice this as much as you can. Then when you get the real TCP dump, you can really figure out what's wrong with it. And then if you have a particular special question or special scenario you need me to analyze and tell or something like that, just comment or send me a message, then I'll try to discuss that as well. Then we'll see you in the next video. Until then, take care, stay safe.